In this video, we're going to be using Hess's law to solve for unknown changes in enthalpy for reactions given other reactions whose enthalpy changes we do know. For our first example, now in this case we're trying to determine this reaction down here, ClF gas plus F2 gas makes ClF3 gas. So this has an unknown delta H. We know the delta H is of the first three reactions. 2ClF gas plus O2 gas makes Cl2O gas and F2O gas. We also know the next two. So we've got to build this final blue reaction out of these first three reactions. To do that, as we did in class, we use this our unknown as a guide. We know from our unknown reaction here that ClF gas, I need one ClF gas as a reactant. Now, in the case of my three reactions I got to build this from, ClF gas only appears in one of them, right here, and it appears as a reactant. That's good, but I have two of them. I need one of them, so I've got to take that reaction and divide everything by 2, leaving everything else the same. So, I have ClF gas plus 1/2 O2 gas makes 1/2 Cl2O gas and 1/2 F2O gas. Now, as we did in class, when you multiply or divide a reaction by a number, the delta H, you divide or multiply by the same number. So here I'm divided by 2, so I got to take the delta H, 167.4, and divide it by 2 also. And I get 83.7 kilojoules for that delta H. Now, looking for the next thing. The next thing I should find in my unknown reaction is F2 gas as a reactant. I need one of them. And in this third equation, I see F2 gas. I see two F2 gases in this as reactants. That's good. I need to divide it by 2 again, however, to get rid of the 2 and have only one of that. So I take the third reaction that I'm given and divide everything by 2. So I have F2 gas plus 1/2 O2 gas makes F2O gas. Again, I divided by 2, so I got to take my delta H of 341.4 and divide it by 2, giving me positive 170.7 kilojoules. Finally, I need ClF3 gas as a product. Well, ClF3 gas, here it is. It's a reactant right now, which means I got to flip the second reaction. Also, I only need one of them, and I have 2 of them. So I got to flip the second reaction and divide everything by 2. So flipping everything and dividing everything by 2. On the left side, I have 1/2 Cl2O gas plus 3/2 F2O gas makes 1 ClF3 gas and 1 O2 gas. Since I flipped everything, that changes the sign on delta H, and I divided by 2, so I've got to take the value given here, 341.2. Oh, I have made a mistake, however. I should fix that now. I have made a mistake in the last line. This isn't 170.7. I divided the wrong number by 2. It actually should have been negative 43.4 divided by 2. I used the wrong number, so that should be negative 21.7 kilojoules. So here I have 341.4, change the sign, so it's negative 341.4 divided by 2, and I get negative 170.7 kilojoules for that step. Now, let's check to make sure that we're adding up to the right thing. So I'm going to add these reactions together now, these 3 reactions on this side. And I'm going to cancel out what appears on left and right in the same number. So, let's look for stuff. I have, on the left, I have a 1/2 O2 here and a 1/2 O2 here. That's 1 full O2 gas on the left. I have 1 full O2 gas on the right, so those cancel. right, what else do I have that cancels? Well, I have 3 halves F2O gas on the left. I have one here and another half there, so 3 halves F2O gas on the right. So those all cancel. Looking through, seeing if there's anything else that'll cancel. I have 1/2 Cl2O gas here, 1/2 Cl2O gas there. Those cancel. And now continue to look through. I don't see that I have anything else that I need to worry about. And so now I can see what I get when I add up all these things. So I have on the left ClF gas plus 1 F2 gas makes ClF3 gas. And that, as you can see, is exactly what I was trying to find. And so at this point, now I do the same thing. I add up the delta H's that I've accumulated. So 83.7 plus a negative 21.7 plus a negative 170.7 gives me a final answer for this delta H of negative 108.7 kilojoules. And that then is the delta H for this unknown reaction. Now, moving on to the next example for one. Here we have our new example, and here we have our new unknown reaction right here. So NO gas plus O gas makes NO2 gas. So I want to find the delta H for that based on these 3 reactions above and their known delta H's. So doing everything like we just did, I know I need an NO gas as a reactant, and I know I need one of them as a reactant. And I have one of them as a reactant in this third reaction. So I'm going to leave it alone because it's exactly what I need. So I have NO gas plus O3 gas makes NO2 gas and O2 gas. And since I left it alone, I'm going to leave its delta H alone, so negative 199 kilojoules. All right, what else do I need? I also need an oxygen atom gas. And the only place I see that is in my second equation as a product. I need it as a reactant. I need one of them as a reactant. So I got to take the second reaction, this here, flip it around, and divide by 2. Divide all the coefficients by 2. So when I do that, I get O gas plus forms 1/2 O2 gas. And since I flipped it, I changed its sign. So it was positive 495, now it's negative 495, and I divided by 2, so I divide that by 2, and I end up with negative 247.5 kilojoules. All right, now, next thing. Looking through it, I need NO2 gas as a product. Well, I have NO2 gas as a product, so that's actually good. So at this point, you might be thinking, let's add up and see what we have, and we can do that. So we can add these together and see what we get. But the problem is, if we did that right now, right, we're going to have a problem with extra stuff. Because if I look, I have an O3 here. That won't cancel. There's nothing to cancel it with, but I don't have an O3 in my unknown. So I now need to add another, before I do this addition, I need to add another reaction down here to get rid of the O3. Well, here I have a reaction with O3 in it. I need, if right now it's on the reactant side, I need to cancel it, so I got to put it on the product side. So I got to flip this first reaction over and divide by 2 to get rid of the O3. So, doing that, flipping it and dividing by 2, I have 3 halves O2 gas makes O3 gas. So I flipped that first one, so it was negative 472 kilojoules. I flipped it, so now it's positive 472 kilojoules, and I divide it by 2, so I divide it by 2, and I end up with 213.5 kilojoules. So now I can add these together and see what I get. So, looking to see what cancels. I have the O3 on the left, I have the O3 on the right, they cancel. That's good. Now, I have 3 halves O2 on the left. I have 1/2 O2 here and 1 O2 here on the right, therefore those cancel. And as far as I can see, nothing else cancels, so what am I left with? I'm left with NO gas plus O gas makes NO2 gas. And that, of course, is exactly what I'd wanted. So now I know that I've got the right reaction. I can add up my delta H's, negative 199 plus negative 247.5 plus 213.5, and I get that the delta H of my unknown reaction is negative 233 kilojoules. So that then is the answer to what's the delta H for my unknown reaction in this case. All right, next reaction, next problem. Here again, I have a more complicated unknown reaction, seemingly, and now I have 4 reactions I'm going to use together to make this. But we follow the same exact path. All right, what do I know? I need C6H4OH2 aqueous on the left. I need one of them. Well, my first reaction has exactly that, a C6H4OH2 aqueous, one of them on the left. So I'm going to take my first equation and I'm going to use it in exactly the way it's written right now. So C6H4OH2 aqueous makes C6H4O2 aqueous plus H2 gas. I didn't do anything, so the delta H stays the same, plus 177.4 kilojoules. So that's my first step. Next thing I look for, next chemical, I need H2O2 aqueous as a reactant. Right now, I only see that right here as a product in the second reaction, so I need to flip the second reaction over to make it a reactant. So if I do that, I get H2O2 aqueous forms H2 gas plus O2 gas, and since I flipped the reaction, I've got to change the sign on delta H. It used to be negative 191.2, now it's positive 191.2 kilojoules. Great. Now, next chemical, C6H4O aqueous. C6H4O2 aqueous, it's already right where it needs to be. I need one as a product. I already have one as a product, so that one's good. Now I need 2 H2O liquids as product. I don't have that yet, so I got to put that in there. Well, I see H2O liquid. It's a product, but I don't have one of them, so I need this fourth reaction, and I need 2 of them. So I got to multiply that fourth reaction by 2. So 2 H2O gas makes 2 H2O liquid. I multiplied the fourth reaction by 2, so I got to multiply the delta H by 2, so negative 43.8 times 2 is negative 87.6 kilojoules. Now, as I'm looking through this, I now have stuff that is not canceling properly. Stuff that I don't want in my reaction, but is still here right now. For instance, all right, when I look through this, in my reaction, I don't have any H2, but there's H2 in this. I don't have any O2, but there's O2 in this. So I've got to get rid of one O2, get rid of 2 H2s. They're both products right now. So that means I've got to take this third reaction, and I got to multiply it all by 2 to get 2 H2s and 1 O2 as reactants to cancel this stuff out. So take the third reaction and multiply everything by 2, the way it's written. So 2 H2 gas plus 1 O2 gas makes 2 H2O gas. And the delta H of that, since I multiplied everything by 2, I take the delta H right now and at negative 241.8 and multiply by 2 and get negative 483.6 kilojoules. So now I think I'm ready, so I add up everything. And I cancel out the things that appear on both sides. For instance, as you can see, I have one H2 gas as a product, another H2 gas as a product. That's 2 H2 gases as product. I have 2 H2 gases as reactant. They cancel. Also, I have 1 O2 gas as a product. I have 1 O2 gas as a reactant. They cancel. Also, I have 2 H2O gas as a reactant. I have 2 H2O gas as a product. They cancel. And looking at it, I don't see anything else that cancels. So now I can write what's left. What's left is C6H4OH2 aqueous plus H2O2 aqueous makes C6H4O2 aqueous plus 2 H2O liquid. And again, if I compare, that's exactly what I was trying to make in the first place. So now I just add up my delta H's. So my final delta H is positive 177.4 plus 191.2 plus a negative 87.6 plus a negative 483.6. And I get negative 202.6 kilojoules as the standard, or as the change in enthalpy for this particular unknown reaction. Moving on to my final example. Again, we have a new unknown reaction, and now I have 5 known reactions. But we still approach this exactly the same way. Now, one thing that's important to note, something new in this. It's an unusual phase. Note this carbon. This carbon has a Gr as its phase. That's solid, but it turns out that's a special kind of solid called graphite. It turns out carbon comes in 2 forms of solid, graphite and diamond. And in this case, we need to specify what we have. So in this case, we specify graphite with just a Gr. That's just a quick-hand way of saying that this particular solid is graphite, which is, by the way, the most common form of carbon solid. Now, we're going to approach it the same way. I need one CaC2 solid as a reactant. Well, here it is as a product, so I got to take this first reaction and flip it around. So CaC2 solid make Ca solid and 2C in the graphite form. Now, since I flip the reaction, I got to change the sign on delta H, so it was negative 62.8. Now it's positive 62.8. All right, continuing on. I need 2 H2O liquids as reactants. So searching through this, well, I have an H2O liquid here, I have an H2O liquid there. I should probably not worry about that yet. Leave that for later because I don't know which of those 2 equations I want to use yet, or how I want to use it. So, moving on to the next thing, calcium hydroxide aqueous as a product. Well, looking through this, the only calcium hydroxide I see is right here. Calcium hydroxide aqueous as a product. I need one of them. This has one of them. It's a product in both cases. I can just leave the third reaction alone. So CaO solid plus H2O liquid makes CaOH2 aqueous. I left the third reaction alone, so leave its delta H alone, negative 653.1 kilojoules. Okay, C2H2 gas. All right, looking through here, C2H2 gas is right there. I need one as a product. This one has one as a reactant, so I've got to flip the fourth reaction over. So I can do that. So I get 2 CO2 gas plus H2O liquid produces C2H2 gas plus 5/2 O2 gas. So in this case, I flip the reaction over. So again, I take the delta H for the reaction and change its sign. It was negative 1300 kilojoules. So now it'll be positive 1300 kilojoules. Okay, so now I'm sort of running out of stuff I can identify. See, now I have 2 H2O liquids as reactants. I needed 2 H2O liquids, so that sorted itself out for us. But the problem now, I have extra stuff I don't want again. For instance, very obviously, I have 2 CO2 gases here, you can see them, as reactants. I don't want them. I don't want C2 or CO2 gas at all because it's not in this reaction I'm looking for. I can solve that by taking this fifth reaction and multiplying it by 2 the way it's written to get rid of, because right here CO2 is a product, here CO2 is a reactant, multiplying by 2 they will eventually cancel each other out. So doing that, I get 2C graphite plus 2 O2 gas makes 2 CO2 gas. And since I multiplied the reaction by 2, I've got to multiply delta H by 2. It was negative 393.5. I multiply that by 2. I get negative 787.0 kilojoules. So once again, things are starting to work themselves out. All right. Now, one problem we happen to have still, however, has to do with, we still have, let's just start canceling some stuff and seeing what cancels and what doesn't, because at this point it's starting to become complicated. So I have two carbon graphites as reactants and as products, so those cancel. I have 2 CO2 gases as reactant and product, those cancel. All right, so looking through everything else, trying to figure out if there's anything else I need to do, I also have a new problem. I can see where my problem is. Here I see a product that I don't want, calcium solid. Note there's no calcium solid up here, so I need to get rid of this product. That means I can take the second reaction, which I haven't used yet, all right? I have a calcium solid as a product I don't want. This has a calcium solid as a reactant, so using it the way it's written will cancel that out. So Ca solid plus 1/2 O2 gas makes CaO solid. I left it alone. I didn't change anything, so we'll leave delta H alone. Negative 635.5 kilojoules. Now back to canceling. I have a calcium solid as a reactant and a calcium solid as a product. Those cancel. Additionally, I see something else. I have 5/2 O2 gas as a product. I have 2 O2 gas here, plus another half. That's 5/2 O2 gas as a reactant, so those cancel. So the 5/2 O2 cancel with these two. That's good. Also, I have a CaO solid as a reactant. I have a CaO solid as a product. Those cancel. And so looking through real quickly now, I don't see anything else that I can cancel out. Note I have 2 H2O liquids as reactants, so those should combine in my final answer when I add up all this stuff. So adding it all up now. As a reactant, calcium carbide solid plus 2 H2O liquids produces calcium hydroxide aqueous and C2H2 gas, which, comparing it, is exactly the reaction I was interested in. So now I can just add up my delta H's to find the answer to my problem. So the delta H for this reaction is positive 62.8 plus a negative 653.1 plus 1300 plus a negative 787.0 plus a negative 635.5. And I get negative 712.8 kilojoules. And that then is the delta H for this unknown reaction. In general, I hope that these examples have helped you better understand how to use Hess's law to solve for unknown delta H's. And hopefully you can go through and try each problem and then rewatch the video for that problem and see if you can get the same answer, which gives you some practice problems where you know the answer.